In this video, we will be finding the volume of a disk. As a refresher, you can find the volume of anything using the measure of an object's length, height, and width, also known as its base times height. Just as a reminder, this is how we find the volume as a cube and the volume of a cylinder. Side to the power of 3 and base times height, which is also equal to pi r squared times height. Now let's look at a shape something like this. How would you find the volume of this? In order to find the volume, we'll use any of the same tactics that we use to find the volume of any other shape. Calculate it using the bases times the heights. You've also already learned how to find the area of obtuse shapes using integration. Now we will be using integration to find the volume of an area revolved around an x or y axis. What you see in the video right now is the graph of x to the power of 2 revolved around the x-axis. Here I'm showing a little bit of a diagram to show you the 3D-ness of that shape. Now here's my first tip for you guys. Whenever you're finding the area or volume of a shape like this, always draw it out. Draw it out on the side, draw it out on the margins. You have to be able to visualize what you're doing in order to understand it. As you probably saw in your packet, these are the two equations you will be using to find the volume of an object perpendicular to its x or y axis. Pause there to see them again. Now let's move on to doing our first practice problem. Here you can see the problem that I have set up. Our first step, like usual, is to draw it out. We are going to be revolving the square root of x around the x-axis for this problem. Now you can see me drawing the equation out so I can visualize it. Now that we've drawn it out, we are going to use its confining points, so the domain and range for this, and then be able to revolve it around the x-axis to form a shape. So like we said, we're going to be using the equation that we showed before in order to find the volume of this. So I have here writing out volume is equal to pi, the integration symbol, a to b r squared dx. Now let's plug in the numbers that we have here. We have the domain of 0 to 4, which is going to be written down, and then r squared. R squared is going to be our equation, our f of x in this situation, which is square root of x. Now you see me just solving it out to find the volume. The volume is now equal to pi times 4 minus pi times 0. We can find this by plugging in what we have to our domain, like we usually do. So we have the volume for this shape revolved around the x-axis is equal to pi times 4 units cubed. Now let's find the volume of this same equation, but revolved around the y-axis. Our first step, as always, to find the volume of something is to draw it out. Here you see me drawing 2 points on this equation, on this graph, so that I can revolve it and show you a cross-section of what this shape will look like. Now, once we've drawn the cross-section, we will revolve this around the y-axis. I've just cut to a point where I've already drawn out the shape, and now I'm writing out the equation again to find the volume of something revolved around the y-axis, which is volume is equal to pi, integration symbol, the domain, and now r squared, but r is now going to be in relation to y instead of x. So we're taking the equation f of x is equal to square root of x, and now changing it to f of x, where x is equal to y squared. Never forget to put dy instead of dx when you're changing it to revolving around the y-axis. Now I'm just solving this equation out by plugging in the numbers to find the final volume. Now we can see that the two volumes of the problems we just solved are 4 pi u to the third and 16 pi u to the third. Thank you guys so much for watching, and I hope this was of some help in finding volumes of things revolved around the x or the y axis.